So as I said, the future performances of building projects mainly improve the sustainable aspects is the main target of today's lesson. So moving on, as an introduction, as we discussed in the previous week as well, the building industry is a vital element of any economy, but it has a significant impact on the environment as well. So it is a vital element of any economy of any country, as well as it has a significant impact to the environment of as well. So with respect to such significant influence of the building industry, the sustainable building principles or the sustainable building approach has the high potential to make a valuable contribution to the sustainable development. So in the previous week, we discussed sustainable development has three main aspects, as you remember: the economic sustainability, the environmental sustainability, and the social sustainability. So when we talk about this sustainable development, the building construction, so the sustainable approach towards the building construction make a valuable contribution as well. The main idea of this sustainability involves enhancing the quality of life, therefore allowing people to live in a healthy environment with improved social, economic, and environmental conditions. So here they have mainly highlighted the social, economic, and environmental conditions because those are the three cores of sustainability. So in order to enhance the quality of life, with respect to sustainability, we need to allow people to live in a healthy environment with improved social, economic, and environmental conditions. So a sustainable project is designed, built, renovated, operated, or reused in an ecological and resource efficient manner. So we need to make sure that we do the designing, we do the building, renovations, operations, as well as the reusing of any building, any project, sustainable project, in an ecological and resource efficient manner. That means an environmental friendly manner. So when it comes to that point, it should meet a number of certain objectives. Those are the resource and energy efficiency. We should make sure that our project is designed, built, renovated, operated, and reused in a resource and energy efficient manner. Then the CO2 and GHG emissions manner. What is GHG? The greenhouse gases. CO2, that is carbon dioxide, and GHG emissions reduction. So we should make sure the reduction of, we should make sure the emission of carbon dioxide and other greenhouse gases should be reduced at maximum level in our building process, renovation process, operation process, as well as the reusing of our building construction. Then we should make sure the pollution prevention. The pollution in the sense not only the environmental pollution, we should make sure the noise pollution and air pollution and other related pollutions as well. We should mitigate the noise, improve the indoor air quality. So after the construction, we should make sure that we have proper air inside the building as well. And the harmonization with the environment. We should match our construction projects with the environment. Otherwise, we can't withstand with the conditions outside the building. For an example, if we are making a building in an, let's say, in rural area, we should make sure that the building should be able to withstand in that particular climate with the cold background, as well as with the all the rainfalls, as well as the maybe the landslides as well. So we should harmonize our building with the environment. So if you have any questions, You are welcome to ask them through the chat, or you can anytime you can switch on your mics and raise your questions as well. So when we discuss about the sustainable building principles, this sustainability and sustainable building principles have estimated that by 2056, global economic activity will be increased by fivefold. Fivefold in sense 5 times as now. And the global population will increase by over 50%. So if we have 100 people now, by 2056, it will be 150 people. And the global energy consumption will have increased nearly by threefold, 3 times. And the global manufacturing activity will have increased at least by threefold. So with the increase of the global population, global economic activity will increase, global energy consumption will increase, as well as the global manufacturing activities will also increase. Compared with other industries, the building industry rapidly growing world energy use and the use of finite fossil fuel. Those are the fuels that we are using in our day-to-day lives. So this finite fossil fuel resources has already raised concerns over supply difficulties. So we know that the petrol, diesel, and those fossil fuels are coming to an end of their supplies. An exhaustion of energy resources and the heavy environmental impacts, for an example, the ozone layer depletion and the carbon dioxide emissions as global warming and the climate change. As results of these changes happen from the building construction or building industry compared to the other industries. So building material production consumes energy. Construction phase consumes energy. Operation phase, once operating a completed building, also consumes energy in order to do the heating, lighting, power, and the ventilation processes. So not only in the buildings construction stage, as well as in the operation stage also, it consumes energy. Building materials consumes energy. Building construction phase consumes energy, as well as building operation phase consumes energy. In addition to this energy consumption, the building industry is increased as a major contributor to the environmental pollution, as in a major consumption of raw materials. With 3 billion tons consumes annually of 40% of the global use and produces an enormous amount of waste. So you can imagine how vast this construction field is. They are the major contributor of the environmental pollution with the major consumptions of raw materials, with 3 billion tons consumed annually, or 40% of the global usage of the raw materials, and it produces enormous amount of waste. So using around 40% of the global raw material usage, as well as in other terms 3 billion tons annually, it produces an enormous amount of waste. So what are the issues in the sustainable building construction? So the sustainable building issues, we can categorize them into 3 main aspects, as well as similar to the three core areas of sustainability: the economic sustainability, the environmental sustainability, and the social sustainability. In terms of the economic sustainability, The main issues are maintenance of high and stable levels of local economic growth and employment. It can be mainly categorized into two subcategories as improved project delivery and the increased profitability as well as the productivity. So the issues are how to improve the productivity, consistent profit growth, how to maintain consistent profit growth, how to have employee satisfaction, supplier satisfaction. We should satisfy employees as well as the suppliers. On the other side, we should of course satisfy the client as well. So client satisfaction by minimizing the defects, shorter and more predictable completion time. So anyway, the clients need very shorter period completion time, as well as they should predict it. The construction workers should predict it in prior. Lower cost projects with increased cost predictability. We should predict the cost as well as in the other side, we should minimize the cost as maximum possible and delivering services that provide best value to the clients, focusing on developing client business. So these are the main issues of economic sustainability. Then when it comes to the environmental sustainability, we can discuss them mainly by avoiding pollution, protecting and enhancing the biodiversity and transport planning. So effective protection to the environment can be achieved by avoiding pollution, protecting and enhancing the biodiversity, as well as proper planning of transport. So in order to do that, we should minimize the emissions of pollution gases. And we should prevent nuisance from noise and dust by good site and depot management. Waste minimization and elimination is another aspect of this environmental sustainability, and preventing pollution incidents and breaches the environment requirements. Habitat creation and environmental improvement, protection of sensitive ecosystem through good construction practices and supervision, green transport plan for sites and business activity. So these are the main things that we should concern when it comes to the environmental sustainability. Next, we should move on to the social sustainability. Before that, in terms of environmental sustainability, we should prudent use of natural resources also plays a major role in building construction field, because that is the major industry which uses around 40% of the resources in the earth. So in order to do that, we should find improved energy efficient method and how to efficiently use the resources. So for that, energy efficient at depots and sites is a major thing, and how to reduce the energy consumption in business activities. Designing for whole life cost, we'll be learning what is this whole life cost in the cost estimation part of this lesson. Use of local supplies and the materials with low embodied energy. Lean design and construction, avoiding waste. So what it means by lean construction is a way of design production systems to minimize the wastages, especially the waste of materials, time, and effort in order to generate the maximum possible amount of value. Use of recycled, sustainability sourced products, water and waste minimization and management. So as I said earlier, next focus should be on the social sustainability. So in the social sustainability, the social progress which recognizes the needs of everyone should be achieved through respecting the staff members of construction work, the working with local communities and the other road or the construction users, and working with partnerships. So when we discuss on the issues on the social sustainability, the main issues are provision of effective training and appraisal. We should give effective training and appraisal to those staff members in order to deal with the other people. Equitable terms and conditions, provision of equal opportunities. So all the staff members or the workers should feel that they have equal opportunity to engage with the work as well as for the promotions. Health and safety and conductive working environment should be maintained. Maintaining morale and employee satisfaction, participation in decision making, minimizing local nuisance and disruptions, minimizing the traffic disruptions and delays, building effective channels of communication, contributing to the local economy through local employment and procurement, delivering services that enhance the local environment, building long-term relationships with clients, and building long-term relationships with local suppliers, corporate citizenship, delivering services that provide best value to clients and focus on developing client business. Those are the major issues that we should address in terms of the social sustainability. Okay. So now we are moving on to the principles for synergistic relationship between these three aspects of sustainability. What are the three aspects? The social sustainability, economic sustainability, and environmental sustainability. So the undertaking of assessments prior to the commencement of proposed activities assists in integration of information relating to social, economic, biophysical, and technical aspects of the decision-making process. The timeless involvement of key stakeholders in the decision-making process is also important. The promotion of interdisciplinary and multi-stakeholder relations between the public and private sectors, contractors, consultants, and non-governmental institutions should take place in participatory and interactive manner as well as consensual manner. The recognition of complexity of the sustainability concepts in order to make sure that the alternative courses of actions are compared. We should compare the alternative actions then and there. This is so that the project objectives and the stakeholders are satisfied with the final action implemented. Who are the stakeholders? Stakeholders of a project is anyone, any personal or institution that are dealing or being affected by that particular project. It includes the client, it includes the contractor, consultant, general public, etc. The use of life cycle framework recognizes the need to consider all the principles of sustainable construction at each stage of project development. So we know that there are several stages of project development. We discussed them in the last lesson as well: design stage, the construction stage of the building stage, maintenance stage, then reusing those things. So we should maintain that the principles of sustainable construction is maintained at each stage of the project's development, from planning to the decommissioning of project. The use of systems approach acknowledges the interconnections between the economics and environment. The systems approach is also referred to as an integrated process or the integrated design process. That care should be taken when faced with uncertainty. Compliance with the relevant legislations and regulations is also important. The establishment of a voluntary commitment to continual improvement of sustainable performance. So we should appoint or establish a voluntary commitment in order to check whether the sustainable performances are improving continuously. The management of activities through the setting of targets, monitoring, evaluation, feedback, and self-regulation of progress. This iterative process can be used to improve implementation in order to support a continuous learning process. The identification of synergies between the environment and the development is also very important. So let's move on to the framework that we were discussing in order to do the sustainable implementation. Sustainable implementation, a framework of strategies and methods. So you can see in this diagram, there are three main concerns of this framework. That is the resource conservation, the cost efficiency, and the design for human adaptation. So the main objectives of this sustainable building construction implementation is the conservation of resources, the efficiency of cost, and designing for human adaptation. So in order to do that, there are different strategies that we can follow. For resource conservation, we can move on to the energy conservation, material conservation, water conservation, and land conservation. So we can categorize them under several subcategories as energy conservation, material conservation, water conservation, and land conservation. In terms of cost efficiency, we can focus on initial cost, what we call as the purchase cost in use, cost values that are related when we are using it, and the recovery cost. In terms of the human adaptation, we can focus on protecting human health and comfort and protecting physical resources. So let's discuss on these three main aspects one by one. So the strategies and methods to achieve the resource conservation. If you remember, we have three main categories as resource conservation, cost efficiency, and design for human adaptation. So in order to achieve the resource conservation, these are the strategies and methods that we can use. Those are the energy conservation, the material conservation, water conservation, and land conservation. That is, those resources can be subcategorized into energy, material, water, and land. So in order to achieve energy conservation, what we can do is we can choose materials and construction methods properly, insulating building envelope, design for energy efficient deconstruction and recycling, design for low energy intensive transportation, developing energy efficient technological process, and use of passive energy design. We'll discuss what is this passive energy in the upcoming slides. And considering the material conservation, we should design for the waste, and we should specify the durable materials to be used, specify the natural and local materials that are available, design for the pollution prevention, and specify non-toxic materials. There are some toxic materials as well. In terms of water conservation, using water efficient plumbing fixtures, design for both dual plumbing, collecting rainwater and harvesting them, using harvesting, employ recirculating systems, designing low demand landscaping, and pressure reduction. Okay, we were discussing on the water conservation, and when it comes to the land conservation, adaptive reuse of existing buildings, locate construction projects closer to the existing infrastructure, and developing non-arable lands for construction. Development of non-arable lands for construction are some strategies that we can use in order to achieve the sustainable implementation of resource conservation. Then when it comes to the strategies of energy input during the life of a building. So during the life of a building, we can input energy as harvest of raw materials, production of materials, and transportation of them first. Then when it comes to the life of a building in the construction phase, operation phase, and the maintenance stage, as well as the deconstruction or demolition or the disposal stage. So those things that again can recover the useful products and then again take them for the production of material stage. So this process will continuous recycling and reuse process. So whatever the material that cannot be recovered from the disposals or the demolitions will be the disposal of waste products. So they will be the waste products that we need to dispose them carefully. So when choosing the materials and the construction method, that choices of the materials and the construction methods are also important in order to reduce the energy consumption of the building through reduced solar heat. Reduced solar heat in the sense it can be a heat gain or a heat loss, thus reducing the air conditioning load. So whatever the heat loss or the heat gain through the building construction or the consumption of energy through solar will be affected for the air conditioning loads in the building as well. Choosing materials with low embodied energy will help you to reduce the energy consumed through mining, processing and manufacturing, as well as the transporting of materials. For instance, aluminium has very high embodied energy because of the large amount of electricity consumed to mine the raw materials. Whatever the true low energy building design will consider this important aspect and take a broader life cycle approach to energy assessment. So we have something called as energy assessment in terms of the construction work as well. So in order to insulate in the building envelope, these are some of the current as well as the future trends. Insulating the building envelope is the most important of all energy conservation measures because it has the greatest impact on the energy expenditure. So this insulation process has a greater impact on the energy expenditure. A well-designed and installed insulation can reduce the amount of heat lost through the building envelope by at least half. So if we have well-designed and installed insulation system, we can uh, actually we can gain the half of the energy lost through the heat. Frost and heat loss will be eliminated with an air tightness strategies where existing vents and chimneys will be blocked, floors and ceilings will be insulated, and walls will be coated with modified plastic. The heat recovery in high temperature areas such as kitchens and bathrooms will achieve optimum energy efficiency through a mechanical ventilation until that takes heat from these areas and uses it elsewhere in the house. Tropical climate. Tropical climate is the climate that we are having in local conditions as well. So in tropical climates, the passive cooling is the most sustainable method of use, which can be achieved in intelligent architectural design. So you can see two buildings in Sri Lanka, which has used passive cooling in tropical climate. In passive cooling, what actually happens is the cool air drawn in from below trees will transfer and the hot air escapes from the upper side windows in the building as well. In tropical climates, it's important to keep the interior of a building cool and it is known as passive cooling. So it is very important to keep the interior of a building in a cool condition and that is what we call as the passive cooling because the reliance on active or the mechanical means is kept on a minimum level. So active cooling is through air conditioning and other aspects. Passive cooling is maintaining the interior of a building cool in natural sources. So in terms of designing the energy efficient construction and recycling materials, we should maintain or we should focus on energy efficient deconstruction methods as well. Deconstruction, in other terms, recycling of materials will cut energy consumption in manufacturing as well as it will save on natural resources as well. Buildings designed for deconstruction will include the disentanglements of systems and reductions in chemically disparate binders, adhesives, and coatings, or thermal, chemical, mechanical means to better separate constituent materials. So they will include a construction blueprint and also a deconstruction blueprint and they will have a barcodes for materials so that the deconstruction contractor will have handling instructions for the material and component upon material. These buildings will have self-supporting and self-stabilizing components, component accessibility designed in and built-in tie-offs and connections points for workers and machineries. These are some theoretical parts that we need to cover. Most importantly, buildings that facilitate reuse and recycling will use non-hazardous materials, bio-based materials, high quality and high recyclable materials. Design for deconstruction offers possibilities for the design of buildings that will close the loop of materials using buildings, and it helps to make the transition towards the zero energy building industry. Designing for low energy intensive transportation will also reduce the emissions causing the air pollution by affecting the amount of fuel used. The reduction of energy consumption in buildings has little impact on the national energy consumption if the urban and rural transportation systems waste energy. An efficient community layout that places schools, shops, and other services close to the homes and businesses, making it easy to get places without driving and offering attractive bicycle and walking paths. It can greatly reduce the vehicle miles traveled per household. So it is a good concept on reducing the energy consumption of uh, related to the transportation as well as related to the land use. This would in turn reduce the amount of energy needed for the transportation while improving the quality of life even before any expenditures are made for the vehicles. Therefore, the design of low energy houses should be combined with an urban design that allows the use of public transportation and bicycles. So you can see the transportation as well as the land use are dealing one with another. If the sites maximize public transportation, if the cities maximize the public transportation, the use of bicycles or the active transport methods, and minimize the use of private methods, the result would be lower costs for energy as well as for the construction of roads, and the less traffic jams and less air pollution as well. Developing energy efficient technological processes for construction, fit out, and maintenance of buildings is also important. An integrated approach to energy efficiency in building processes would need to be instigated by the project team right from the beginning to achieve the target energy consumption levels. Use of passive energy designs such as natural ventilation, landscaping by vegetation, use of water bodies for evaporation and cooling, orientation of building can help to achieve the thermal and visual comfort inside the building, so that there is significant reduction in energy consumption by conventional air conditioning and artificial lighting in a building. So we can reduce the energy consumption for the air conditioning as well as the lighting inside a building if we use this passive energy designs. Architects as well as the designers of buildings can achieve energy efficiency by studying the macro and microclimate of the site, applying solar passive and bioclimatic design, and taking advantage of the natural resources on the site. So you can see it is not just designing a building. We should uh, focus on all these aspects in order to have a sustainable design. So in sustainable practices, we have sustainable energy consumption. We can utilize the low flow fixtures. We can reduce the stormwater runoff. That means stormwater or the rainwater can be used for in terms of harvesting, in terms of gardening, maybe for the bathrooms, the solar panel installation, and the vehicle charging station. So these are the things that we can implement inside a building in order to have sustainable practices inside it, within it. In terms of the materials conservation, so up to this point, we were discussing on the energy conservation. In terms of the material conservation, design for waste minimization is important. The construction industry is the major waste generator, as we discussed earlier, which causes several environmental, social, and economic problems. So waste takes from the spent or unwanted materials generated from the construction and demolition processes, and the prevention and reduction of waste in the construction of housing can save the considerable amount of non-renewable resources. An increasing body of scholarly work, notably that produced by has demonstrated that the building designers have an important role to play in construction waste minimization. So as it says, the building designers from the planning stage onwards or the pre-design stage onwards have an important role to play in construction waste minimization. Waste minimization should be addressed as part of the project's sustainability agenda throughout the design process by the application of the three key designing waste principles, namely reducing and recovering construction waste, reuse and recycling the storage and disposal of construction waste. That is very important. The three key designing out principles are reducing and recovering construction waste, reuse and recycling, and the storage and disposal of construction waste. Reducing and recovering, reusing and recycling, storage and disposal of construction waste. So reducing and recovering construction waste can be achieved in different manners. The most effective measure of this reducing the environmental impact of construction waste is by primarily preventing its generation and reducing it as much as possible. This will reduce the reuse, recycling, and disposal needs, thus providing economic benefits as well. An analysis has shown that recovery reduces the amount of waste and greenhouse gas emissions, and it saves energy and it reduces the use of raw materials as well. Recovery of useful energy and the materials from waste has also been emphasized as one of the most important environmentally friendly practices for achieving energy savings to alleviate the pressing energy situations. Reuse and recycling products, it reduced general environmental impacts and particularly prevented or particularly the use of resources and waste creation. The importance of these alternatives, such as recycling and reuse for re-entering construction materials and components in the production chain, has been already presented in the literature. Reuse of building materials is an alternative for the reduction of construction and demolition waste when renovating and demolishing buildings by performing building construction, which enables the recovery of building parts as functional components such as bricks, windows, tiles, differently from traditional demolitions in which parts are transformed back into the raw materials to process. Designers should assess whether any existing buildings on site could be partly or completely refurbished in order to meet the project's need. Carrying out a pre-demolition audit of buildings that are being demolished to discover whether any materials or components can be reused is also important. Designers should also assess whether the deconstruction and flexibility can be considered, or whether it is a priority. In situations where construction waste could not be prevented and recovered, they need to be stored in an appropriate manner to kept under control. Where the non-hazardous construction debris and construction debris classified as special waste are landfilled in either municipal solid waste landfills or in landfills that only accept the construction debris. Around the world, decisions on the types of waste acceptable at landfills were entirely based on site-specific risk assessment. Licensors controlled the quantities and types of waste to be accepted, and often, in the case of hazardous waste, specified maximum loading rates for particular waste or component substances, and the designers need to be aware and take into consideration policies and guidelines for material storage and dispose at the design stage of construction project. To be honest, you might feel like boring in this part of the lesson because it's full of theories, but it's not very hard part to follow. So if you go through these notes again and again, you'll be able to answer the particular questions that will be raised through this part of the lesson. Specifying the durable materials. The sustainability of a building can be enhanced by increasing the durability of its material. And a material or component or a system may be considered durable when its useful service life is fairly comparable to the time required for related impacts on the environment to be absorbed by the ecosystem. Materials with a longer life relative to other materials designed for the same purpose need to be replaced less often. This reduces the natural resources required for manufacturing and the amount of money spent on installation and the associated labor. The greater the material durability, the lower the time and resource required to maintain it. Durable materials that require less frequent replacement will require fewer raw materials and will produce less landfill waste over the building's lifetime. So when specifying the natural and local materials, natural materials are generally lower in embodied energy and toxicity than man-made materials. They require less processing and are less damaging to the environment. Many, like wood, are theoretically renewable. When natural materials are incorporated into building products, the products become more sustainable. The use of building materials sourced locally can help lessen the environmental burdens, shorten the transport distances, thus reducing the air pollution produced by vehicles. Often local materials are better suited to climatic conditions, and these purchases support area economics as well. For instance, the decorative use of marble quarried halfway around the world is not a sustainable choice. Steel, when required for structural strength and durability, is a justifiable use of material that is generally manufactured some distance from the building site. Pollution prevention measures taken during the manufacturing and construction processes can contribute significantly to the environmental sustainability. Although these products may have an initially higher off-the-shelf price, choosing products that generate higher levels of pollution exploits the environment. Therefore, pollution comes in form of air, water, and soil. However, emissions to soil are hardly discussed in the life cycle assessment literature, and the data available are very limited. So we will have a separate lesson regarding this life cycle assessment of a building. In the construction industry, soil pollution is mainly a problem at the construction site. It may also be a problem in the extraction of some minerals when the waste is deposited, especially hazardous waste. This wastewater is often released directly into the streams and can contain toxic substances as well. The means of transport is also important. Emissions from road, air, and rail transport are major causes of photochemical smog, of which the main components are carbon monoxide, nitrogen oxide, hydrocarbons, and ozone released by the action of sunlight on organic compounds in the lower atmosphere. Because of the bulk and the large quantities involved, moving construction materials contributes very significantly to the total pollution emissions from transport. By becoming aware of which manufacturers use environmentally sustainable manufacturing methods, specifying their products and avoiding goods produced through highly polluting methods. Building designers can encourage the use of marketing of sustainable construction materials as well. Specifying non-toxic and less toxic material is also an important part. Non or less toxic materials are less hazardous to construction workers as well as to the building occupants. Many materials adversely affect indoor air quality and it exposes occupants to health hazards. Some construction materials such as adhesives, paints, sealants, cleaners, and other common products contain volatile organic compounds, VOCs, and emit dangerous fumes for only a shorter time during and after installation. That is why we basically smell like, very toxic smell is there once the paints are applied on walls, but after a certain period of time, it is not. Others can contribute to air quality problems throughout a building life. So by using building materials with lower or non-toxic or non-existent levels of toxic substances, environmental health problems can be avoided and the need for air scrubbers will be reduced. So in terms of toxic materials, lead is a heavy metal commonly found in roofing materials. Then we have polyvinyl chloride, polyvinyl chloride, what we call as PVC, wood treatments, halogenated flame retardants, asbestos, cadmium, volatile organic compounds, VOCs, and silica. These are some toxic materials used in building constructions. So next we are moving on to the water conservation. According to the UN World Water Development Report, WWDR, it indicates that the water for all our users is becoming scarce. Scarce in the sense, if you remember, we discussed in the very first day, scarce. So the scarcity is limited resources for unlimited needs. It is leading to a water crisis nowadays. The effects a sector can have on the environment are nowhere more apparent than in the building industry. Water used to operate buildings is a significant component of a national water consumption. However, this is not the only form of water consumed throughout a building's life cycle. Water is also consumed in the extraction, production, manufacturing, and delivery of materials and products to site and the actual on-site construction process. Utilizing water-efficient plumbing fixtures such as ultra-low flow toilets and urinals, waterless urinals, low flow and censored sinks, low flow shower heads, and water-efficient dishwashers, washing machines, and in order to minimize the wastewater. And designed for dual plumbing to use recycled water is also important for toilet flushing or for grey water systems that recover rainwater or other non-potable water for site irrigation. Non-potable water in the sense the water which is not suitable for drinking. Potable water is the water which is suitable for drinking. Grey water is produced by activities such as hand washing, and does not need to be treated intensively as sewage. It can be recycled in a building to irrigate ornamental plants or flush toilets. Collecting rainwater using rainwater and greywater storage for irrigation purposes greatly reduces the consumption of treated water. Rainwater can also be used for household applications, including drinking water as well. In fact, people in many regions of the world have traditionally relied on harvested rainwater for their water supply. Employ recirculating systems for centralized hot water distribution, which conserve water which is typically wasted by users while waiting for warm water to flow from a warm water faucet. Designing low demand landscaping using plants native to the local ecosystem also reduces the water consumption on site. Since these plants have been adapted to the local rainwater levels, thus eliminating additional watering. The efficiency of water can also be improved by means of underground drip irrigation systems, which reduces water loss caused by evaporation of surface water during watering and after rain. You can see in this diagram some rainwater harvesting systems. So they are collecting the rainwater, they are treating them, they are storing them in, and then using them into the usage of the building as well. It is not a very new method. It has been used in the ancient times as well. You can see in this diagram. Pressure reduction. Because the flow rate is related to pressure, the maximum water flow from a fixture operating on a fixed setting can be reduced if the water pressure is reduced. For example, a reduction in pressure from 100 pounds per square inch to 50 psi pounds per square inch at an outlet can result in water flow reduction of about 1/3. Then moving on to the land conservation, land is an important resource upon which the construction industry depends. Land use through urban expansion has been identified as a growing problem in both developed and developing world. Although more land may be reclaimed from the ocean, land reclamation on a large scale is undesirable since it could severely interfere with ecosystems. Soil erosion, groundwater contamination, acid rain, and other industrial pollutants are damaging the health and plant communities, thereby intensify the challenge and necessity to restore habitats. Sustainable design must develop a respect for landscape and expand more effort understanding the interrelationships of soils, water, plant, communities, and associations, and habitats, as well as the impacts of human users on them. Land can be conserved by adopting a policy of zero expansion of existing urban areas. This could be achieved by adaptive reuse of an existing building, thereby eliminating the need for new construction. In addition, placing sustainable building projects within easy access of public transportation, medical facilities, shopping areas, and recreational facilities would prevent the expansion of built environment and occupation of agricultural and ecosystem area. So this basically discussed regarding the four aspects of energy conservation, material conservation, water conservation, and land conservation. So it covers the resource conservation strategies and methods in order to achieve the resource conservation. So do we have anything to be clarified before winding up the session? No questions? No questions from your end? So shall we wind up the session for today? So from next week onwards, we will have the lectures on the usual time slot from the Tuesday from 8 to 10. So only this week and last week only we have this on Monday. So from next week onwards, we will have it on Tuesday. Okay. So we won't have any other lectures for this week for building economy. We will have the next lecture on next Tuesday. Are we clear? I hope next Tuesday is not a holiday. It's not a holiday, right? Yeah. Okay, so let's wind up the session for today. Thank you for your cooperation, guys, and have a nice day. We will meet again on next week. And as I got, I have received your assignment submissions last week as well, and it seems 2 or 3 students have not submitted the assignment. So if those students can contact me over the phone or through email, it would be better because I don't want to give any students a 0 mark for their assignments. If you haven't submitted your assignment last week, please contact me via email or through over the phone. So we'll wind up the session for today. Thank you for your cooperation, guys. Have a nice day.